question number 3. So question number 3 again gives us a graph of an exponential function, all right? And we need to identify which function best represents that graph, all right? So again, to be able to identify the graph, we're going to need to identify the x and y intercepts, okay? So the y-intercept, if I look closely right here, the y-intercept looks like it's exactly right here. So the y-intercept would be when y is 6, okay? So that coordinate would be 0, 6, okay? If you look here, we technically do not have an x-intercept because it did not cross this line. It went exactly on the line, okay? So in this case, we have no x-intercept. So again, we have no x-intercept, all right, technically. However, this is where it is approaching. So again, it is approaching when x equals 0, but it's never crossing when x equals 0, all right? So let's go ahead, let's try to identify the equation that best represents this, okay? So what we're going to do is that we're going to plug in 0 for x and see if we get 6 for the y, all right? So again, I'm going to plug in 0 for x here, but I already know that this one is not correct because what? It looks like y equal mx plus b. And you know that y equal mx plus b is linear, all right? And again, we're looking at exponential functions. Again, we're looking at an exponential. So again, this would be incorrect because again, this is a linear function. We need exponential. This one also is what? It looks like y equal mx plus b. And y equal mx plus b is what, guys? It is linear, all right? So this one is also incorrect without even using my information here, okay? Now, I'm going to need to use the information here. I'm going to plug in 0 for my x and see if I get 6 for my y. So if I have 6, parentheses 1 over 3, 0 for the x, 1 over 3 to the 0 power, anything to the 0 power is 1. So what you will be calculating here is 6 times 1, all right? 6 times 1, because 1 over 3 to the 0 power is 1, all right? 6 times 1 is 6, all right? So again, more than likely, this is my correct answer. I'm going to test the next one to make sure, because if I plug in 0 for my x, I would have 2 parentheses 1 half to the power of 0. And we know anything to the power of 0 is 1. So technically, I'm seeing 2 times 1. Because 1 half to the power of 0, that's the only thing you're raising to the power of 0. Because that's the only thing that's attached to this exponent. Right? So that would mean that you have 1 now here. And because you have a parentheses, you multiply. 1 times 2 is 2. Okay? So again, looking at that one right there, guys, we got 2, not 6. So this would be incorrect. Okay? So now let's identify the statement that will be represented for the domain. So you know that domain is what values? X values, okay? So to look at my X values, I'm looking at left to right, okay? So if I look from the left on my graph, I see an arrow. So because I see an arrow that's on the left side, that means that I would technically be starting at negative infinity. Because if my graph extended wider and wider forever, it would be going more and more to the left. And if we follow our graph, it went to the right. And I see an arrow that was going on and on and on forever. So it was going to positive infinity. All right. So the domain for this one, guys, would be that x would be from negative infinity to positive infinity. Because again, if my graph expanded more and more and more, it would be going forever. All right. So this would be the result. Okay. This is incorrect. So now we're going to look at the range. So we're going to look from the bottom to the top. So if we look from the bottom to the top, I didn't start all the way down here because again, my graph kind of straightened up, all right, or became constant right here. So from here upwards, that's where I traveled. So I traveled from when I was at here, so when I was at 0, all the way upwards. So if I went upwards forever, I would be getting more positive, so I would be going from 0 to positive infinity, all right? Or rather, all the numbers larger than 0. This says negative infinity to positive infinity. That would be incorrect, because again, I am not starting all the way down here. But I am starting from 0 and getting more and more positive. So this says y is greater than 0. So that would be the answer I would use, because that would mean that y is getting more and more positive. Okay, because y is greater than 0. So now we're going to look at if the function is constant. If you see, we had a constant rate right here, but for some reason it shot all the way up. All right, so that means it is not constant. All right, so it's not constant. All right, so this one would be incorrect, that it is constant. All right, and then the next thing we're going to do is identify the asymptote, so the point that it's approaching but never crossing. So we see when x is 0 and when y is 0. When y is 0 would be right here. So this is when y equals 0, right here. All right, did we cross when y equals 0? Yes, we did cross it. Did we cross when x equals 0? No. So because we're looking at where we're not crossing, we did not cross here. So that would be the asymptote. So again, the asymptote is where you do not cross. So where you do not cross. Okay? If I had y equals 0, I crossed that. Here, I did not cross when x equals 0. So that's why it is an asymptote. This is incorrect. All right? So good luck, guys. Good luck.